Hello. Today we're going to be working on amplitude and vertical shift of sine and cosine curves. So the first thing you should be able to do is we're going to be able to graph sine and cosine curves using basically 5 points. We know that sine starts at the midline, goes up to a height of 1, back to the midline, down to -1 as a minimum, back to the midline. And it takes 2 pi to make that one full rotation. Okay, so we're going to be graphing these sine and cosine curves typically with 5 points. Okay, for cosine, I hope you remember cosine looks kind of like a curved V. It starts at a height of 1. Remember, it's 1 unit to the right of the y-axis, goes to the midline of 0. We have a minimum of -1 because it's 1 unit to the left of the y-axis over at pi, and then right back up to look like this kind of curved V. Okay, so let's talk about amplitude. Amplitude will be the coefficient of the sine or cosine curve. So we would have a number here in front of sine, like 2 or 5 or 7 or -8 or -1/3. And what we're going to talk about today is how does amplitude affect the graph of the sine curve? So we're going to do a little discovery. And we need our graphing calculator, and we're going to set it to be into certain modes. So the first thing we're going to do is we're going to make sure, whoops, I had it right, that we're in degree mode, and then we're going to quit out of there. Next thing we're going to do is we're going to change our window. So our window, instead of going from like -10 to 10, we're going to have it go from 0 to 4 pi. Now your calculator is going to change it to a decimal, but that's okay. And the increments that we want to see will be pi over 4. So every 1/4 pi we will see. Okay. And we just need our minimum and maximum. We're going to focus from -5 for our lowest value on the screen up to 5. We'll keep those scales the same. And if you look at the graph now, what you'll see, a height of 5, a height of -5, and it goes from 0 to 2 pi with each of these little tick marks representing pi over 4. All right, so let's get into it. We are going to graph our parent function, y equals sine of x. Let's take a look at that. So as you know, sine starts at 0. At pi over 2, it goes to a height of 1. At pi, it goes back to 0. At 3 pi over 2, it goes to a height of -1, which is its minimum value, and then back to 0. So it has a y-intercept of 0, a maximum of 1, and a minimum of -1. Let's go back to y equals, and we're going to keep that parent function in there, but now we're going to put this 2 times the sine of x. If you can think back to what a 2 in front of x squared would do with a parabola, it would make it higher faster, right? Well, it's the same thing here. It makes it go twice as tall. Back to center, twice as low, back to center. So it amplifies each height by 2. Now, 2 times 0 is 0, which is why we keep these values here. Okay, and here we go. So we have a y-intercept of 0, maximum height of 2, minimum height of -2. And just notice, it just repeats itself again. Remember, this goes to 4 pi. What we really are focusing on is one full rotation around the circle. All right, you can probably predict what putting a 3 in front would do, right? It's going to make it go 3 times as high. So you can see this has a much bigger amplitude. The y-intercept is still 0. The maximum is now 3, and the minimum is -3. So the amplitude is really increasing the height. Let's take a look now. We're going to focus on cosine. So we have y equals, and let's clear all of these out. Okay, and I hope you're actually doing this with me because you're going to need to know how to do this on your own. But we're going to graph y equals cosine of x. And you already know it looks like a V, right? So it starts high, comes to a minimum, back to center, and then up high again. The y-intercept is 1 for the parent function. The maximum is 1, and the minimum is -1. So let's go ahead and do the next one, which says to do 4 times the cosine of x. And as you can imagine, that's going to make all of the heights multiplied by 4. So we have a y-intercept of 4. We have a maximum value of 4 and a minimum of -4. Okay, and then what do you think this negative is going to do? Think back to last year with all the parabolas that you did and all the functions that you studied. What would a negative do? Well, hopefully you remember that it reflects it vertically. So what you'll see here is 1 times -3 brought us down here. -3 times 0 got us here. Okay, here our low point was -1. So -1 times -3 gives us a height of 3. So it has been reflected. So the y-intercept is -3. The maximum is 3 and the minimum is -3. So the big idea here is that the amplitude will increase. I can't write it because it's going to come out too messy, but the amplitude will increase the high and low amounts. Okay, make them taller. And please write down also that a negative will reflect the graph. It's going to be super important that you know that. Okay, so make sure you write all that down. Which kind of leads us to the next page. So right here, again, I think you should write it again, that it reflects the graph. Okay, having a negative reflects it vertically. I can't write. And then in terms of pi, remember that the period is 2 pi. So it takes 2 pi to make the full up, down, back to center. And the same thing for cosine. It takes 2 pi to make one full cycle, which looks like this. So you are going to try to do 11, 12, and 13 on your own. When you're done with those, we're going to go ahead and do the next few problems. So stop the video, do these problems, and then we'll see how you did. Okay, so take a look at these graphs and let's make sure you did okay. One thing I did want to point out to you, I don't think I mentioned it, is that the amplitude will always be positive. So on number 13, where we had the amplitude, it said -4 times the cosine of x, the amplitude is still 4 because the swing from the midline, and this would be the midline right here, it's still 4 units above and 4 units below. So we always express amplitude as a positive value. Okay, so we're going to turn to the next page.
Excuse the interruption.
Okay, sorry about that little announcement. So we're going to go back and let's clear out all of these functions that we have in our calculator. And let's do y equals the sine of x for our first function. So we have that in there. Okay. And for our second function, now we're going to be talking about the vertical shift. So we're adding 2 after the sine of x. So again, think back last year to a parabola. What would happen if you added a value outside of the x squared? Okay, hopefully you remember what it would do. It would bring it up 2 units. Okay, in this case, +2 brings it up 2 units. So the vertical shift is 2. It's exactly what you see here. Now, what is the maximum? Well, the maximum, here's 1, 2. Oh, I can't draw on this. This is very annoying. Well, the midline is right here at 2. The maximum is 1 unit above that, and the minimum will be 1 unit below that. So 2 plus 1 gives us 3. The vertical shift of 2 minus 1 gives us 1. So that gives us our maximum and our minimum. And where did I get that 1? Well, it's our amplitude. Okay, this is all going to come together in a little bit. But what would you think about subtracting 3? Okay, so hopefully you know subtracting 3 is going to bring the sine function down 3 units. So let's take a look. And there it is, down 3 units. Notice our y-intercept is here, 1, 2, 3. Now it's here. So our vertical shift, it has gone down 3 units. Again, for the maximum, we take that vertical shift and we add what our amplitude is. So our maximum height will be -2. For the minimum height, we have -3 minus the amplitude. So we go down as low as -4. Okay, so hopefully this is coming together. We're going to clear all of these out and we're going to do the same thing for cosine. And you know what? The same thing's going to happen. So there's cosine of x, our parent function. And now we'll do cosine of x. Remember, you have to close those parentheses and then add 2. And what's going to happen here? It was shifted up 2 units. Okay, just like before. So the vertical shift is 2. The maximum, again, we do 2 plus 1, which is 3. The minimum is 2 minus 1, which is 1. And you can see that right here. Okay, but the whole midline went up 2 units. The whole thing went up 2 units, right? The whole graph. And now for the next one, I do want you to change it. If it doesn't already say it, we're going to put -3 here. Okay, instead of, or actually, let's put +3 there. +3 instead of +2. Okay, so we have y equals. We'll keep that parent function right there, and we're going to make this +3. And what do you think is going to happen? There we go. It was shifted up 3 units. Okay, and the maximum, again, we take the vertical shift plus the amplitude, which is 4. For the minimum, we take the vertical shift minus the amplitude, which is 2. Okay, so if we do have the high and low points and we wanted to find what the vertical shift was, for say if I gave you a graph, you could just average the max and min values, right? 4 plus 2 is 6, divided by 2 gives us 3. So check out number 20. See if you can predict what the vertical shift would be. Okay. Hopefully you think the vertical shift is to go down 1 unit. And now remember, we have -1, that's our vertical shift, plus the amplitude, which I would prefer to look at as 1.5, sorry. And then the minimum, we do the same thing, except we subtract. So our minimum value would be -2.5. And we're going to go ahead and graph that. Okay, so we'll graph that. We can clear all of this out. We don't need that. But let's go ahead and I'm going to put 1.5 just because it's easier on my computer, times the sine of x. Close that parenthesis, and then, whoops, I should have subtracted, -1. Enter. Let's see what that graph looks like. Dropped down a unit. Remember, the y-intercept used to be here. Dropped down a unit. Maximum height is 1/2. Minimum height is -2.5. So it all worked. Okay, stop this video. You know what to do. Okay, hopefully you can take all that we've done and put it together. You know what? Maybe I'll do the first one with you just to make sure. So first of all, every single one that we've done so far has had a period of 2 pi. They won't always, but for now they do. We have to find our max and min, but let's first identify our vertical shift. The vertical shift comes from this, so it goes down 2 units. The amplitude, remember, is the coefficient in front of sine or cosine, so it's 3. To find the maximum, remember, we take the vertical shift and we add the amplitude. So -2 plus 3 is 1. -2 minus 3 is -5. So let's go ahead and let's graph this. We're dealing with sine, okay? First thing I like to do is with the vertical shift, I like to put a little dashed line because that kind of shows me where the midline is. So everything has been shifted down that many units. We know for sine, we start at center, halfway through we hit center, and at the end of a full cycle we hit center. At pi over 2, or halfway between the beginning and the middle, we go to our maximum value, which would be 1. And halfway between the middle and the end, we go to our minimum value, which would be -5. So our function is going to look like this. So that's how I would suggest you do these. Identify the period is always going to be 2 pi for now. I would first do the vertical shift, then I would do the amplitude. For any maximum, we do vertical shift plus amplitude. For the minimum, we do vertical shift minus the amplitude. Okay, and I would suggest also making sure you do this dotted line where the midline will be. Okay, so good luck, go to it, pause the video, and then come back and see if you got the right answers. All right, let's see how you did. Okay, please check your answers. Okay, here are the last two. This one I thought you might have trouble on because of the negative out in front. So notice that the vertical shift is -3. Like we did drop the function down 3 units, but the amplitude we still call 2. -3 plus 2 is -1 for the maximum height. You can see it right here. -3 minus 2 gives us a minimum height, which is -5. Because it was reflected, our cosine function, which looks like a V, is now an upside down V. Okay? So hopefully this was helpful. Have a wonderful day, everybody.